Day 2 of our practice problem starts with sample problems. That's it. It says, a helicopter hovers above a fire, dumps a large bucket of water. How far does the water fall? In the first 3 seconds. And so in the first 3 seconds, we know that we have t equaling 3. We know there are hidden givens. Vi equals 0. And A equals negative 9.8 meters per second squared. And in the first 3 seconds, we know that we're looking for how far the fall is, so x equals. If we're doing x equals versus t, that would be x equals VIT plus 1/2 AT squared, and our x is equal to 0 times 3 plus 1/2 negative 9.8 3 squared. We type it into our calculator, 1/2 negative 9.8 t squared and we know that that was a negative 9.8, so I can just go ahead and change it to a negative. So I've got 44.1. 44.1 meters per second in the downward direction. So that's how far. Well, how far doesn't actually care about the negative sign, so I won't count off if you have more information, but I will count off if you don't have enough. If you said 44.1 and I asked for what is the velocity, oh, this is how far it falls, so that's meters. So if you leave it as a distance instead of displacement, I wouldn't count off in this problem because it's how far. But if I ask for what is the displacement and you don't have the negative, I will count off. In the third second, we've already had 2 seconds pass. And we can subtract off those first 2 seconds. We could do the exact same thing. T equals the first 2 seconds. And we have VI, and we have A, and we're still looking for x, and we find out that we have x equals VIT plus 1/2 AT squared. And so we can say x equals 1/2 negative 9.8 times t squared, 2 squared. So 4 cut in half is 2. We get negative 19.6. Now, we're not done because we went 44.1 in the first 3 seconds, and we're going to get rid of 19.6 in the first 2 seconds. So 44.1 minus 19.6 equals 20. Okay, I almost didn't carry the 1. 24.5 meters. And that's a downward direction. So negative 24.5 meters is where it went. Now, you could think of it in a couple of ways. We don't have the VI here for just the third second. That's why we did it this way. You could have solved for the velocity at that moment in time before, and then just calculated the interval from 2 to 3 seconds. Or the other thing that you could have done is just it's the same thing, that our speed is increasing and increasing from 0. Now again, this is speed. Velocity, it would have been an upside down graph of this. But that as it goes up, we are ignoring second 1, second 2, and we just need the area for this third second. Okay, so you need to be able to either find the average velocity from 2 to 3 seconds, which we know is 19.6 to 39.4, but there are other ways to go about that.